Hi, my name is Rito. I'm a postdoc at Caltech, and I study the origins of our universe.
What is the universe made of?
Yeah, so that is a really good question because we don't have a good answer. Because if we knew, it would be. So what you and I are made of are atoms, right? The simple atoms you will learn from the periodic table and whatnot. But majority of the universe is not explained by atoms or the building blocks of atoms themselves. It's full of dark matter and dark energy, and the words dark here really show that we know nothing about them. We do know some simple properties. So dark matter is something that kind of behaves like we do in the sense that it has mass. Apple and a pineapple. Pineapple's heavier. It has mass like that. But it doesn't interact. So it's this, imagine you have a baseball, you feel the weight, but somehow when you try to throw it or it goes through the wall, it doesn't interact, just passes through like ghosts. So we see it indirectly via its gravitational pull, i.e. again, mass. But we don't know what it is. And I spent much of my graduate school trying to understand this dark matter. And the other thing that also exists is something called dark energy, where we know even little. And all we know is it's some mysterious entity that is pushing space-time away, kind of elbowing everything to stretch out. Beyond that, we really know very little about the contents of our universe. And it's not clear if we can find it out by doing laboratory testing, although many of us are doing this. Sometimes we may have to look back into the cosmic history, again, how the universe formed, and do what I would call archaeology, and see if there are hidden signals that you can sort of carve out and see what dark matter and dark energy are.
How are you going to find out?
Right now, I'm trying to do this with telescopes that look back in time. In doing that, I'm realizing that the standard way we take pictures with our standard telescopes may not be good enough, because we need a lot of eyes on the sky, and they have to be very sensitive because these signals are so dim, they're weak. And so I'm trying to get new ideas from the field of quantum mechanics, as you may have heard of, and apply them to these telescopes.
Wow. Do you know what the shape of the universe is?
Somewhat, yes. So there is only so much of the universe we can see, and in what we see, it's very flat. It's could have been very exciting, could have been what we call the curvature. When you go through a valley, there's a curvature to it, or you're on a hill, there's a curvature. It could have had such curvatures, but we see it to be pristinely flat. And it goes on forever, as far as we can see.
Why do you think kids should be excited for science?
Everyone should be excited for science, because we live in a world where our interaction with the world, whether you're enjoying a chocolate or playing with the ball or whatever, is connected with understanding why it is so, where is it going, where did it come from, what happens if I do this to it. And I still think like a child. I like to poke at things, drop things, throw things, and see what happens. And that's the best way to enjoy it, as well as understand where we are and what we are doing.
Yeah. Thank you for coming.
Absolutely. Pleasure to hang out here. Yeah. All right.